So I'm sure that they have probably showed you how to do it like the dimensional analysis way, but the way that I learned it is a lot easier. And this is pretty much what the nurses do as well. If you can remember your constants, like your conversions, it's going to be pretty easy, when to multiply by 1,000 if you're going from milligrams to grams, or if you're going, divide by 1,000 if you're going from grams to milligrams. But the one that you're always going to want to know, and once you get this down, it's going to be easy, is your conversion for pounds and kilograms. So 1 pound equals 2.2 kilograms. It's always going to be your constant is 2.2 if you're ever going to have a weight question. And then the formula that I always use for when you want to figure out if it's for, a pill or you're going to draw it up out of a syringe, a vial, is going to be your desired dose, which is D, equals what's ordered over what you have. And then that's going to be your first part always. And then you can eventually, if it's going to be a weight question, you're going to have to multiply it by, whatever. Well, I'll wait until we get there. We'll just start with this one because these are basic ones. So your patient is ordered to receive 5 milligrams of Ativan intravenously. How many milliliters will the patient receive? Record answer to the 10th. The label is 15 milligrams per 15 milliliters or 1 milligram per 1 millimeter. So the way we want to get 5 milligrams, always use your lowest one. There's 1 milligram in there. So you're going to do D equals 5 milligrams over 1 milligram. And you're going to multiply. I'll put it in here, but it's per 1 milliliter, so I'll just multiply by 1 ml, cancels out, and you get D equals 5 mLs to administer. You have an order to administer 3 milligrams of morphine. How many mils will you provide to your patient? Record answer to the nearest tenth. There's 4 milligrams per 2 milliliter. So our desired dose is, we got our 3 milligrams is what we want over, there's 4 milligrams total in the bottle. And then this time we're going to multiply this by 2 mLs. Let me get my calculator out because sometimes I'd be stupid. 3 divided by 4 is 0.75. Multiply that by 2. And you get, round to the nearest tenth, 1.5 milliliters. Next, you have an order to administer 5,000 units of heparin. How much will you inject for each dose? Round answer to the nearest tenth. Don't get tripped up on the units. It's there to trick you thinking that you have to do conversions, but you don't have to. And we're going to still do the same thing. You're going to want D equals 5,000 units over, there's 5,000 units per 1 ml. I'll cancel out. 5,000 divided by 5,000 is a 1. Times 1 is 1. Gonna get 1 ml. That was kind of easy since technically the answer was right in there. Next, you need to administer 250 milligrams of amoxicillin orally. How much will you prepare for 1 dose? Gonna be the same thing. Desired equals, we started off with 250 milligrams and dividing that by the total, which is 125 milligrams. and that's per 5 milliliters. We're always going to take that and multiply that at the end. So 250 divided by 125 is 2 times 5. You're going to want 10 milliliters drawn up for the dose. And then a medical surgical patient has an order for cefazolin, 1 gram every 12 hours. Cefazolin is dissolved in 100 milliliters of normal saline and is ordered to be infused over 30 minutes. The tubing drop factor is 60 drops per ml. Okay. This, you are still going to use the same setup. You won't even technically... Yeah, you won't even need the dose for this because we just want to know the drop factor, what it's going to be over 30 minutes. Now, if this was to say, let's say, 1 hour, you would need to change that to 60 minutes. Always convert for the drop factors into minutes. So if it gets to be infused over, let's say, 5 hours, you're going to multiply 5 hours times 60 minutes. And that gives you 300 minutes. So that would be kind of the example. So in this case, wouldn't even need to worry about the 1 gram over 12 hours. We know that there is going to be 100 milliliters of the solution. So we're going to want to start with what's required is 100 milliliters. And this makes sense too, because if you think about it, if we need to get drops per minute and we have 100 mLs of saline and the drop factor is 60 drops per milliliter, there isn't anything else in this problem that gives you grams or milligrams, so we don't have to worry about the dosage. Now, if it was supposed to be like, the patient weighs, 30 kilograms, and you need to multiply that. You know what? I won't even get ahead of myself. But we're going to do 100 mLs over your time to be infused. So that's always going to be your equation setup is D for when you have a drop factor is D equals total ml being infused divided by total time in minutes. So 30 minutes, they give us 30 minutes right there. Now you're going to multiply that by your tubing drop factor, which is 60 drops per 1 ml. Those end up canceling out from cross multiplication. You're going to do 100 divided by 30, and you're going to multiply that by 60. And you're always going to want a whole number for your drops, and this is going to end up coming out to be 3.3 repeating times 60, which is 199.99, so that rounds to 200 drops per minute. And then I can check the answers down here. We got 5 milliliters, 1.5 milliliters, 1 milliliter, 10 milliliters, and 200 drops per minute. Now, let me go to one that has a little bit more in depth with conversions. Okay, so it's going to be the same thing. 675 milligrams is ordered, supplied, and 225 milligrams in 5 mLs. How many milliliters do we need? So we're going to do desired, D equals 675 milligrams divided by 225 milligrams per 5 milliliters. That is going to give us, so that's going to be 3 times 5, which is going to be 15 milliliters. Next order is 250 micrograms by mouth every 6 hours. The patient weighs 105 pounds. You have a bottle on hand that reads 0.2 milligrams per ml. How many milliliters should you give per dose? So right off the bat, break everything down and do your conversions ahead of time. If we know that 1 pound is 2.2 kilograms, then we can take 105 and divide it by 2.2, which is going to give you 47.72. Never round your kilograms. Always round after you are finishing the problem. You don't want to write 48 because then it's going to screw up the dosage calculation, and it probably won't be right. So now we need to convert micrograms. You can either do milligrams to micrograms or micrograms to milligrams. I would say micrograms to milligrams is going to be easier to convert. And basically, what you're going to do is divide by 1,000. Or if you know that 1,000 is going to be 3 places to the left, if you remember moving the decimal places, we can just move this 3 places and that's going to give you 0.25 milligrams. Or you can just do 250 divided by 1,000 and that's still going to give you 0.25. Now that we have all that done, we can go forward. You're going to have your desired dose. D equals, we're going to take our 0.25 milligrams, our converted factor, and divide it by 0.2 milligrams. Now we're going to take our weight, which was 47.72, and we're just going to put that right in here. And then our last part, per milliliter, we're just going to multiply that by 1 milliliter. And upon doing the math, you're going to take 0.25 and divide it by 0.2, which is going to give you 1.25. We're going to multiply that by 47.72, and then times 1 is itself. And the answer you're going to get is 59.65. Doesn't say round on there, but I'm assuming it meant it. And you're going to get 60 milliliters for your answer. I can double check that down here. 10. 105 divided by 2.2. Make sure I did that right. 0.25 divided by 0.2. What did I do wrong on that one? I have a feeling that's not right on there. But on here, there is 0.2. Okay, we're going to skip that one because I don't think that's right on the answer key. I'm pretty sure I did that right. So we're just going to move on, forget number 2, but a doctor orders 225 milligrams orally for a patient weighing 58 kilograms. Now it's already converted in here. Oh, wait a minute. I actually know what I did wrong for number 2. You don't even need to know. Essentially, let me double check to make sure I got that right, actually. I think I just did an extra step. 1.25. Okay, yep. So it wasn't even asking, actually. It wasn't going to be like it's 250 milligrams per kilogram. They're trying to trick you up in here just by putting the weight in here. You don't even have to do this. You can just multiply these answers by 1 milliliter. That's going to give you 1.25 mLs, which is the answer. And it's going to be the same thing for the next one, too. Don't get hung up on the weight unless it's like number 4, and we'll get there. But for number 3, we're going to do D equals 225 milligrams. You have on hand 50 milligram tablets scored. How many tablets should you give per dose? You're going to do your 225 divided by 50, which is going to give you 4.5 tablets. Okay. Next one. A doctor orders 5 milligrams per kilogram intramuscular. Patient weighs 38 pounds. On hand, you have 70 milligrams per milliliter. So I'm going to underline what I know. I'm going to figure out my kilograms first, which is going to be 38 divided by 2.2, which is going to give you 3.63 kilograms. We're going to do the same thing again. So we're going to do D equals, what we ordered is 5 milligrams. On hand, we got 70 milligrams. Multiply that by your 3.63. And then you have 1 milliliter, which I got from right here, per mil. We're going to work this out. We're going to do 5 divided by 70. It'll give us 0.07142. And you're just going to multiply that by 3.63. Times 1. Altogether, you were going to give, if we're going to nearest tenth, it comes out to be 0.25928. Rounded down is going to be 0.3 mLs. And it should be right. Wait a minute. 50 milligrams per kilogram. Did I screw something up again? Oh my god. Yep, I just made a simple error. Okay. That's not 3.63. Apparently I just have clumsy fat thumbs tonight. It actually comes out to be 17.27. Everything else is right. So we're going to do 5 divided by 70 times 17.27. In reality, it's going to come out to 1.2335. Rounded, it's going to be 1.2 mLs, which is the answer. Next, doctor orders 0.02 grams per kilogram in 2 divided doses to a patient weighing 148 pounds. Label reads 20 milligrams per ml. So in order to get grams to milligrams, you're going to take grams and multiply it by 1,000. Or move your decimal place 3 points to the right. We're going to do 0.02 times 1,000. So 0.2 grams is 20 milligrams. Let's write that down on the side there. It's going to be divided into 2 doses. We'll worry about that at the end. To a patient weighing 148 pounds. So we're going to do 148 divided by 2.2, which is going to give you 67.27 kilograms. And everything else we can now set up. So we're going to do D equals 20 milligrams over label reads over 20 milligrams. Multiply that by our weight in kilograms, so 67.27. Then multiply that by 1 ml. So 20 over 20 is going to give us 1 times 67.27 times 1. So it's going to be 67.27 total. But then we're going to need to divide that as well, which is going to give us, because it's going to be split into 2 doses, 67.27 divided by 2. D equals 33.635 once it's the round to the nearest hundreds. So our final answer is going to be 33.64 mLs. And that is the correct answer, is 33.64. Always double check when it says 2 divided doses. Always divide your answer by 2 at the end, and you'll get the correct per dose. Now, I'll skip the 6. I'm just going to go to 7. Now, it did take me a little bit to memorize, how many milliliters an ounce. 8 ounces, there's 240 milliliters. 6 ounces, there's 180. 4 ounces is 120. So if you know those 3 constants, then you'll always be able to add up from there. If they give you like 12 ounces, you can take an 8 and a 4 and then add those up in milliliters. Always remember that the pounds, 1 pound is 2.2 kilograms. And then your teaspoons and tablespoons. Also, 1 cup is 8 ounces, which is 240 milliliters. Once you get those down, it's going to be pretty easy from there. But I'm going to write down to help that 1 teaspoon. Oops, write it down here. 1 teaspoon is 5 milliliters. And 1 tablespoon, however you abbreviate it, is 15 milliliters. So for this one, an order calls for 650 micrograms per kilogram for a patient weighing 51 pounds. You have on hand 3.5 milligrams per teaspoon. How many ml should you give per dose, round to the nearest 10th? So we're going to first need to convert our micrograms to milligrams. And we can just divide that by 1,000. So 650 divided by 1,000 gives you 0.65 milligrams. I'm just going to write 0.65 milligrams. We also have 51 pounds, so we're going to need to convert that. So 51 divided by 2.2 is 23.18. Oops. 23.18. And we're good from there. So we're going to do the same setup again. D equals 0.65 milligrams over 3.5 milligrams. Multiply that by our weight, which is going to be 23.18. And we know that 1 teaspoon equals 5 mLs, and we want ml, so we're just going to write 5 mLs on there. Then we're going to do our mass, so 0.65 divided by 3.5 gives you 0.1857. Multiply that by 23.18, which gives you 4.30, and then multiply that by 5, which is going to give you 21.5242, and we want the nearest tenth, so that's going to be 21.5 mLs. Down to number 7, 21.5 mLs, and that's correct. And then here, like I said, once you get these kind of conversions down, you'll be good. And I can pretty much run through these. Now there's 16 ounces in a pound. I'm going to write that one. 16 ounces in a pound. 1 kilogram. 2.2 kilograms equals 1 pound. 5 mLs equals 1 teaspoon. 1 gram is 1,000 milligrams. 16 ounces is 1 pound. There are 3 teaspoons and 1 tablespoon. And then there's 8 ounces and 1 cup. And then 2 tablespoons and 1 ounce. And then down here is your simple conversions. So let me know if you like me to do more of these. I think I have because we have to do these every semester, so I have tons of them with calculating drops per minute. And figuring out times and stuff like that. And here's a little example down here of this same kind of equation that we use. Desired over have times your quantity is your answer. So let me know if you would like me to do more of like the drip calculation ones, because I don't think I did a lot of those. And yeah, and reach out to me if you need any help.